Somewhere in the cold black silence far beyond the planets, a machine built in the 1970s is still whispering back to Earth. Its memory is smaller than a modern car key. Its transmitter is weaker than a refrigerator light bulb. And yet, after nearly half a century in space, Voyager 2 is still sending data from a region no human technology was ever expected to survive long enough to explore. That alone would be extraordinary. But what makes this story unsettling is not just that Voyager 2 is still alive. It is what it found out there. Because when scientists expected to see a clear boundary between our solar system and interstellar space, Voyager 2 discovered something that did not behave the way the textbooks said it should. No dramatic magnetic flip. No clean cosmic doorway. Just evidence so strange that it forced researchers to confront a disturbing possibility. Maybe the edge of our solar system is far more complex than we ever imagined. Voyager 2 exists because of one of the rarest opportunities in astronomy. In the late 1970s, Jupiter, Saturn, Uranus, and Neptune aligned in a way that happens only once in about 176 years. That alignment meant a spacecraft could use gravity assists from one giant planet after another, gaining speed with each encounter. NASA knew the chance was too rare to ignore. So in 1977, it launched two nearly identical spacecraft, Voyager 1 and Voyager 2. They were expected to last only a few years. Instead, they became legends. Voyager 2 flew past Jupiter and Saturn, then became the first and only spacecraft ever to visit Uranus in 1986 and Neptune in 1989. It crossed the asteroid belt, survived the outer planets, and kept going into a region humanity had never touched before. That is what makes Voyager 2 feel almost mythical. It is not just a spacecraft. It is a survivor from another technological age, still functioning where it was never meant to be. After more than 4 decades in space, Voyager 2 arrived at the one place scientists desperately wanted to understand: the border of the heliosphere. The heliosphere is the vast magnetic bubble created by the Sun and inflated by the solar wind. It surrounds the planets and shields us from much of the radiation coming from deep space. Somewhere far beyond Pluto, this bubble was expected to end at a boundary called the heliopause. Researchers thought that when Voyager crossed that line, the signs would be obvious. Cosmic rays would surge. Plasma density would rise. And most importantly, the magnetic field direction should shift dramatically as the spacecraft left the Sun's domain and entered the wider galaxy. But that is not what happened. Voyager 1 crossed first in 2012 and detected some expected changes, but not the clean magnetic switch scientists predicted. Then Voyager 2 arrived in 2018 and confirmed the mystery. It also detected changes in particles and plasma. It also crossed around 120 astronomical units from Earth. But once again, there was no dramatic magnetic flip. The boundary existed, yet it did not behave like a simple dividing line. That discovery shocked researchers because it suggested the heliopause is not like stepping through a doorway. It may be more like walking through coastal fog, where land and sea blend together in ways that are hard to define. Instead of a neat border, the Voyagers found turbulence, interaction zones, and overlapping influences. That meant one of two things. Either the heliosphere interacts with interstellar space in a far stranger way than predicted, or the very idea of a simple solar system boundary was wrong from the start. The deeper scientists looked, the stranger it became. Models predicted the heliosphere should expand and contract with the Sun's 11-year activity cycle. Stronger solar wind should push the boundary outward. Weaker solar wind should let it move inward. Yet Voyager 2 crossed at roughly the same distance as Voyager 1, even though solar conditions were different. The models did not line up. That means the giant magnetic bubble surrounding our solar system may not have a clean, stable shape at all. It may twist, ripple, stretch, distort, and change constantly under pressure from both the Sun and interstellar space. In other words, after decades of theory, humanity may still not understand the true shape of the cosmic shield protecting every planet we know. What makes this even more incredible is that Voyager 2 made this discovery while operating in conditions that should have ended the mission long ago. The spacecraft is powered by radioactive plutonium slowly decaying into electricity. Every year it loses more power. NASA has had to shut down heaters and non-essential systems one by one just to keep it alive. Yet it continues. Still sending whispers across billions of miles. Still teaching us. Still exploring. One day, Voyager 2 will fall silent. Its instruments will shut down. Its final signal will fade into the noise of space. But the spacecraft itself will keep traveling for thousands, then millions of years through the dark between stars. And maybe that is what makes its story so haunting. A machine built in the 1970s, running on fading power and ancient technology, traveled farther than almost anything humanity has ever made just to tell us one astonishing truth. The map is incomplete.